Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to solve some of the problems related to friction. So, in the previous session, we have covered what is the introduction to friction and theoretically what is the friction, what is the limiting friction, and types of friction. Here, the static. There are two types of frictions. One is static friction, another one is dynamic friction. Again, dynamic friction is also known as kinetic friction, and this dynamic friction is divided into two parts. Again, two types. One is a sliding friction, another one is the rolling friction. So here, there's the sliding friction, another one is rolling friction. Here, what is the limiting friction? It is the maximum value of the friction at which the body just begin to move or begin to slide over the surface of the other body. So it is known as the limiting friction. Now, one more term is that not only limiting friction here, normal reaction. So here the direction of the limiting friction is always in opposite to the direction of the motion of the body. So when thrust is here, it is in the direction, the limiting friction is opposite to the thrust. So the normal reaction which acts always normal to the surface. Here the surface, if we consider, it is 90 degree with the surface. So these are the terms we covered, and one more thing is that what is the loss of limiting friction? The common law on all in the static friction and dynamic friction and also limiting friction is that the common law is that the direction of the limiting friction force is always opposite to the direction of the motion. And examples, there are various examples we studied here. The examples are related to the limiting friction. So when we walk on the road, when car moves, when the brake applied, so all these friction forces are related to the application of limiting friction. Now here the normal reaction, as we have studied, that always acts normal to the surface. If it is a horizontal plane, 90 degree, and for the inclined plane, also it is like, okay, weight acts vertically downwards, passing through the center of gravity. And the normal reaction is a normal reaction. Reaction always normal to the surface. So here there is the maximum value of the limiting friction. This diagram shows the relationship between the static and kinetic friction and also limiting friction. And here the frictional force related to applied force is the thrust on x-axis, and also friction is a dependent parameter. Applied forces is independent. How the friction force? There are two: the limiting friction force, static friction force, and kinetic friction force. From this figure, we can understand the value of the limiting friction is always more than the kinetic and the static. There are two. The junction between the static and kinetic is the limiting friction force. Okay, is the limiting friction. Limiting friction term we use, but it is a limiting friction force. Okay. So another term is the angle of friction. The angle of friction, the angle at which the body is going to slide down, is the angle of friction. Is the inclination is there, okay, and at the angle it is going to, if we increase the alpha, when it is 0, it is a horizontal plane. There is no sliding motion. If you gradually increasing the alpha, what will happen? At particular angle of alpha, this body is going to slide down. So what will happen? That angle is known as the angle of friction. Okay, that is known as angle of inclination. That angle of inclination is known as the angle of friction. Now, finally, the coefficient of friction. How can we know the coefficient of friction? Coefficient of friction is the parameter with which we can quantify, or we can measure, or we can describe about friction. So this coefficient of friction mu equal to F by R. What is the F is? The limiting friction force. What is the R? The R is the normal reaction between two bodies or two surfaces. So this is the relation that mu equal to F by R or tan phi, where phi is known as the angle of friction. Now these are the terms. Now in this, there are certain questions we can understand before going to go for solve the problems. So what is the question one here? What is the other name for limiting friction? Okay, because by this question and answers, we can observe better the concepts of friction. Okay, so what is the other name for limiting friction? The other name for limiting friction is the maximum value of the friction. So this limiting friction is also known as is the maximum. Other name for limiting friction is the maximum value of the friction is the other name for limiting friction. That is the question 1. Next, question 2. What is the difference between the limiting friction and the static friction? Yes, here we have studied what is the difference between static friction and a limiting friction. So the static friction is mainly here is a self-adjusting force, because it comes into play when the body is lying over the surface of another body without any motion. That is the static friction. So when that body, that at that time, but when you apply the thrust on the body tends to move. There limiting friction occurs. Here, when that body overcomes the force of static friction, so the maximum value of the static friction is reached, which is known as the limiting friction. The maximum value of the static friction, or when the body tends to move, immediately the maximum value of the friction increases its value. Static friction force value it will be increased. That maximum value of the static friction is known as the limiting friction. Now let us solve. We are going to solve the problems which are related to the friction. Let us begin with problem 1. It's a very simple model. Let us start. So your body of weight is 300 newtons, is lying over a rough horizontal surface, rough horizontal plane, having the coefficient of friction, that is mu equal to 0.3, and it is 300 newtons, it is 0.3. What is, we have to find out the magnitude of the force, okay, which can move the body. Okay, find the magnitude of the force, which can move the body while acting at an angle of 25 degree with the horizontal. Now here we have to find out what is magnitude of the force while acting at an angle of 20 degree, here 25 degrees with the horizontal surface. That's what from this description, the diagram we have drawn. This is the weight of the body. So the weight of the body is 300 newtons. It is on the horizontal surface, which acts vertically downwards 300 newtons. The normal reaction always acts normal to the surface. According to the law of transmissibility of the force, the normal reaction, instead of acting here, it is passing through collinear with the passing through center of gravity of the body. Now here the given weight of the body W equal 300 newtons, the coefficient of friction mu equal to 0.3, and angle made by the force with the horizontal is 25 degree. This alpha is not angular friction. Okay. Now let P is the magnitude of the force which can move. There is the P is the magnitude of the force which can move the body, and F, where F is the force of the friction, which always acts in opposite to the direction of the motion. Now we have to resolve this P into horizontal and vertical components. If you resolve it, this P is the force acting here. I want to draw. This P is the force acting. So this angle is 25 degree. If you resolve on horizontal and vertical, we go to the module 1, the lectures in the previous sessions, then we can understand the resolution. Here it becomes a P cos 25, and another one vertical is the P sin 25 degrees. Now when it is now here resolved that F equal to the frictional force, F is in this direction. Okay, F is in opposite direction. F equal to, if you apply resolving the forces horizontally, that F equal to P cos alpha, that is P cos 25. P times cos 25, that is 0.9063. Now resolve vertically from this here. What is the R? Is the vertical upwards and W is downwards. The positive R here, algebraic sum, equilibrium equations, if you apply R upwards, okay, R plus P sin 25 degree minus 300 minus 300 newtons equal to 0. From that, R equal to 300 newtons minus P times sine 25 degrees. That's what is the equation. Here we used sigma V equal to 0, vertical equilibrium equation. Here we use sigma H equal to 0, algebraic sum of all horizontal forces equal to 0. That is, we can understand here F and P cos 25, both are only horizontal. Now this P made resolved into 2. The effect of P is divided into 2 components, such as P cos 25 is horizontal component and P sin 25 is the vertical component. Okay. Now P cos 25 is horizontal and F is horizontal. P cos 25 algebraic sigma H equal to 0. If we consider the positive and it is negative, upward is positive, downward is negative. P cos 25 is the positive minus F equal to 0. Then F equal to P cos 25. Alright, P times 0.9063. This is equation 1. This is another equation, R equal to 300 minus P sin 25. This is second equation. Okay, second equation. Now, we know the force of friction F equal to, we know the force of friction F equal to P cos, F equal to, what is that? F equal to P, that is P times 0.9063. Another one is that F equal to, what is the force of friction? F equal to mu times reaction, F equal to mu R. What is that F equal to? That F equal to P times, that is 0.9063 equal to mu times R. What is that R? If you substitute here in the equation, P times 0.9063 equal to mu times, from this equation, from equation 2, what is that R equal to? 300 minus 0.044226 P. This is what equation. Okay. Now, mu times R, mu is 0.3 times, what is that? R equal to 300 minus P times 0.4226. So, 90 minus 0.1268 P. So, 90 equal to, if we simplify it, we can get it the unknown P. From this equation, 0.9063 P equal to 90 minus 0.1268 P. From that, what is that P? The P equal to, if you simplify it, we'll get it 87.1 newtons. This is the answer for this. So, we need, the body tends to move. At what force the body tends to move? The 300 newtons force, the weight of the body, which an inclination of 25 degrees, if you want to move the body, the effort is required is 87.1 newtons. So, that means here, in order to move, because of why it is the reduction force is required, less force is required in order to move, the more weight of the body. The law of simple machine principle here. What is happening here? When the P is moving, that means if the angle affects, reduces the force in order to move the body. So, at this position, at this 25 degrees angle, the P will be moved with the force of how much? P will move 25 degrees. How much force is required? 87.1 newtons. So here, this is the case for 25 degrees. If you consider the case for, if it is 45 degree, what will happen? If it is 60 degree, what will you can do it? You can practice this one model. Change the angle alpha 2, then alpha make it as this angle of inclination, make it to 30 degrees. This angle of inclination, that is alpha 1, make it to 45 degrees. Then alpha, again make it to 60. Then here, under these considerations, you can compare at what angle we need less force. Okay, so let us begin. The methodology remains the same. Okay, you follow the same method. You can solve the problems by changing the angle of inclination. We consider alpha equal to as 25 degree. Alpha equal to 25 degree. Make it 25 plus 20, 45. 45 plus 20, you make it as 65. So, under this already 25 we calculated. Then alpha equal to 45 degrees at alpha equal to 65 degrees. What is that inclination? What is the effort is required? You can solve 2 more by changing the angle, and you can compare at these angles, these 3 angles, what is the and observe the p values. So let me make clear. Alpha equal to, what is the angle of alpha? Yes, alpha equal to 25 degree, and what is p values? At alpha equal to 45 degrees and alpha equal to 65 degrees. So what is the values of p? You calculate here. Alpha equal to 25, we got it around 87.1 newtons. At alpha equal to 45, what is the value of p? And alpha equal to 65, what is the value of p? And you can compare these 3 and come to conclusion that the optimum, the less effort, optimum force, that is meant less effort is required in order to move 300 newtons body. Okay, that's what we can make it here, 300 newtons. Okay, now that is the first model. Next we go to model 2. In model 2, a body is resting on a rough horizontal plane. Yeah, it is also same problem. The horizontal plane requires a pull of 180 newtons inclined at an angle 30 degree to the plane just to move it. It was found that the push of 200 newtons is inclined at 30 degree to the plane just to move that body. They move the body. Determine the weight of the body and the coefficient of friction. Again, once again, please read here. In order to 2-3 times you have to read, then you can understand what to do, how to solve. A body resting on a horizontal plane required a pull of 180 newtons inclined at an angle of 30 degree. 180 newtons effort is required with an inclined at a 30 degree with a 30 degree angle to the plane just to move it. This is a horizontal plane only. Okay, horizontal plane. Okay, a body weight we don't know. In order to move it, 180 newtons is required with an angle of 30 degree. It was found that the push of, push of 220 newtons inclined at 30 degree. Here it is the pull. Another case is that push. Another case is the push. What is that push is how much? 220 newtons. The second case, what is the inclination? 30 degrees. That is a W. From these 2 cases, what is the weight of the body and 2 unknowns? What is the coefficient of friction? W and mu are to be calculated. Okay, that's what. Let us begin. The case 1. What is the case 1? First case. First of all, consider a pull of 180 newtons acting on the body. We know that in this case, the force of friction F1, that is 180 newtons. Okay, what is the F1? Force of friction will act towards the left. Okay, this is the force of friction F1. Now for this case, what W we have to calculate? Understand? From those 2 cases. So we have to find out F equal to, again, resolve the case. This 180 newtons cos 30, F1 equal to 180 newtons cos 30. That's the equation 1. That F1 equal to 180 times, what is the cos 30? That is 155.9 newtons. The second equation, sigma H equal to 0. Next one is sigma V equal to 0. What is the vertical forces? What is vertical equilibrium? R1 upwards, R1 minus W plus 180 sin 30 equal to 0. Then from this, R1 equal to W minus 180 sin 30. Sin 30 equal to 1 by 2, that is W minus 90. This is okay. Now R1 equal to W minus 90. Another equation is F1 equal to 155.9 newtons. Now we know that what is that F1 equal to? F1 equal to mu times R. What is the F1? 155.9 newtons equal to, what is the mu? We have to find out what is that R, W minus 90. This is the equation. This is the one equation. 155.9 equal to mu times W minus 90. This is the equation. The second case, we have to find out. Now consider a push, that is 120 newtons. The angle of inclination is 30 degree. Now 120 newtons, if you are pushing like that, what is the friction force? Opposite to the motion of the body. Then F2 becomes in this direction. Again you apply sigma h equal to 0 and sigma v equal to 0. What is sigma h equal to 0? F2 positive minus 220 cos 30 equal to 0. That is F2 equal to 220 cos 30. That means F2 equal to 190.5 newtons. Then sigma v equal to 0. What is sigma v? If you resolve it vertical component downward, that is 220 sin 30. Then what is the forces here? R2 upwards positive minus W minus 220 sin 30. That is R2 equal to W goes plus 220 sin 30. Sin 30 is 1 by 2. That is 110. This is WR2. We know that F2 equal to mu times this R2 here. Normal reaction. What is that F2? Calculated. F2 equal to 190.5 newtons. That equal to mu times. Mu is unknown times R2. This is another equation. There are two equations, two unknowns. That is, one equation is the equation 1. As I told you, that is 155.9 newtons equal to, yes, mu times W minus 90. Another one is 190.5 equal to mu times W plus 110. So you can make it, how to find out? Make it either equation 2 by equation 1 or equation 1 by equation 2. If you do, dividing the equations, so 155.9 newtons by 190.5 equal to mu times W minus 90 by mu times W plus 90. Mu get cancelled. From this W minus 90 equal to W plus 110. If you make it after getting this cross multiplication, then you'll get the W. That is W is 991.2 newtons. Substitute this W value in one of the equation weight above equations. That is 155.9 equal to this equation. That is 155.9 equal to mu times W minus 90 in this equation, that equation 1. 155.9 equal to mu times, what is the W value here? 991.2 minus 90. From that we will get it mu value. Mu equal to 0.173 newtons. 0.173, there is no unit. So mu equal to, we got it as 0.173. And W equal to 991.2 newtons. Yes, W equal to 991.2 newtons. Here, understand, there is inclination, the effort. What is the effort is required here? The effort is required. What the values? W, we got it as 991.2 newtons, and mu equal to, what is the value of the mu? 0.173. 0.17. These are the answers, we got it. Point is that now you can compare it. Here 180 newtons, yes, is required. Less force is required. For this, in order to pull, but the same weight, that is how much weight is? 991.2 newtons with the same 30 degrees. If you want to push, how much angle is required? 220 newtons. How much force is required? 220 newtons force is required in order to push the 991.2 newtons. The same weight pulling, you may think that pushing equal to pulling. No. That's what meaning is here. The pulling force is less than the pushing force. For the same angle of inclination. They both are making the same angle of inclination, same coefficient of force, same weight. For the same weight and the same coefficient of friction, for the same weight of the body and the coefficient of friction remains the same. But we can understand the pulling effort, the effort for pulling of the same weight of the body, that is 991.2 newtons, required, the effort required is less in comparison to pulling effort is required is less in comparison to pushing effort. The pushing force is 220 newtons. 220 newtons you have to push. But whereas pulling 180 newtons. The 40 newtons less effort is required for pulling. Okay. This is what here the point is. For the same weight, the weight is that 991.2 newtons. So this is what our interpretation and coming to conclusion. So in practical, if you want to move the body, instead of pushing, if you pull, you need less effort. All right, that is what conclusion from this. From this problem. Okay. For this also, you can change. You can find out for the same weight of the body. For the same weight of the body, you can apply for this year. You can consider another problem you can solve by using this model. The case is that you give the same load, same coefficient of friction. The load is somewhat 1000 newtons weight of the body. The coefficient of friction is, you can give it as 0.173. Okay. What is the effort required for pulling? The angle of inclination theta. Similarly, another one is that 1000 newtons case, 1000 newtons load, and the coefficient of friction is 0.173. How much effort is required for pushing? The angle of inclination is the P1 and the theta 1 is P2. Yes, you can consider it as a theta 1. For the same angle of inclination, here the angle theta 1, the same is same, theta 1. But the effort for pushing and the effort for pulling, you can find out for the same weight. So by using this, for this case, you can find out what is P1 and what is P2. Okay. You can observe what is required. So definitely, from this already previous case study we have already solved. So P1 should be less than P2. Okay. The answer for P1 should be less than P2. So after finding out, you can come to this conclusion. Okay. The next case, the next problem is very, very important. This is a problem. Okay, you can solve it here. So there are very, very important. Here there are two blocks A and B of weights 1 kilonewtons and 2 kilonewtons. So weight of the block A is 1 kilonewtons and weight of the block B is 2 kilonewtons, or in equilibrium position as shown in figure. If the coefficient of friction between the two blocks as well as the block B and the floor, between two blocks means block A and block B, another one block B and the floor is remain same, that is 0.3. So mu AB equal to 0.3, mu B floor equal to 0.3. Is the floor as plane, horizontal plane, 0.3. Now here find the force P required to move the block. Yeah, not this force P. Already fixed at one end. This is the force P required to move. Which block? Not block A, block B. No, to move the block B. So here you apply the principles. What are the things, prerequisites required from solving the above two problems? We came to conclusion is that what are the things we applied, how to solve, how to crack the problems, or how to solve the problems of the friction is that the first step is that draw a free body diagram. Draw free body diagram. Okay. The second one is that apply equilibrium conditions, sigma h equal to 0, sigma v equal to 0. The third is that after applying it, yes, sigma h equal to 0, sigma v equal to 0. The third step is that apply F equal to the frictional force equal to mu times R. This is the equation. So after getting to know it, these are the three steps are to be followed in order to find out the unknown parameter. By using the input parameters, we can find out the unknown parameters, P or anything, the coefficient of friction, sometimes weight of the bodies, etc. Okay, so here how to solve the problem, just to give you a glimpse, and next session we are going to study in detail level how to make it, draw free body diagram mu A, how the friction force is applying, the force, there's some tension will be here, resolve this tension into resolve it into horizontal and vertical t cos 30 and t sin 30, apply equilibrium conditions, and between A and B, how the direction of the friction force. So the friction force will act in this direction here, between A and B. And in order to equilibrium here, the friction force will be in this direction. So here, the friction force between floor and the block B will be in this direction. Okay. Now, let us give a glance what we have studied in summary. Summarize the whole session what we have studied here. In this session, again we recapitulated the definitions and the introduction part of the friction, and we introduced again, we revised here what is the normal reaction, what is the friction force, what is the limiting friction, what is the relation between limiting friction and normal reaction, that is known as the coefficient of friction. And we solved the two models, especially one is on the horizontal plane, it's simple model, which is having the effort, having an inclination of 25 degrees. And the model 2, there are two cases, and we have to find out here the efforts P are given here, push and pull, but we have to find out the weight and the coefficient of friction. All right. And one more thing, in the starting of the session, in the middle of the session, we answered some of the questions which are frequently come across the two questions. Yeah, the mainly two questions we covered here. What is the difference between static friction and limiting friction, and what is the other name of the limiting friction? And one more question also we can understand here, there are different questions we can extract from the fundamentals of the friction. So two questions mentioned here, some more questions that you can also answer the questions. What is the difference between limiting friction and kinetic friction? Okay, what is the limiting friction and kinetic friction? So this kinetic friction, after the limiting friction, it is under when the body is in the motion, the coefficient of friction is known as the kinetic friction. So which value, limiting friction value is greater or larger value in comparison to kinetic friction? Yeah, yes. So limiting friction value is more larger in comparison to the coefficient of kinetic friction. And what is the difference between static friction and kinetic friction? Static friction occurs when the body is at rest. Kinetic friction comes into the picture when the body is in motion. Okay. And the maximum value of the friction is known as the limiting friction. Now, what is the relation between the frictional force and normal reaction? Okay, the relation between friction and normal reaction, that is the mu equal to F by R. So the output of the relation between the coefficient limiting friction, the frictional force, and normal reaction, it gives the coefficient of friction mu. All right. Can you give some of the examples of what are the more examples in what are the examples of the coefficient of friction, examples of the friction? The examples of the limiting friction is that when the vehicle is moving, so if you apply the brakes, the frictional force between the surface of brakes and the wheel surface gives the maximum friction force. Yeah, that is one of the applying the brakes in your car, and also walking. This is also application of the friction force. When you are rubbing the two hands becomes, you can understand, getting heated up because of the friction force. Yeah, two frictions rubbing. And also mopping with the cloth, mopping the floor with your cloth, that is the friction. That friction force helps to clean the surfaces. And one more examples are brushing your teeth, very simple example, that is also due to friction force, the move due to friction between the teeth and the brusher, okay, bristles of the toothbrush, what will happen, the dust particles will be removed, cleaning takes place. So these are the various examples. You can think more, what is the application of the friction? then finally you come to conclusion, wow, everything is friction only. All right, with this we can stop the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.